Let's take a look at this example. Again, we're supposed to prove that the left side is equal to the right. I'm going to start this time from the right side. Let me copy this down. We have 2 cotangent x over 1 plus cotangent square x. This is equal. I'm going to use right now the reciprocal relations, and I'm going to write that in the numerator I have 2 times 1 over tangent x over 1 plus 1 over tangent square x equals. What I'm going to have? I have in the numerator 2 tangent x over, in the denominator I have fraction plus 1. 1 I can rewrite as tangent square x over tangent square x plus 1 over tangent square x. Let me remind you, so in order to add 1 to 1 over tangent square x, we're supposed to convert 1 to the fraction and find a common denominator. That's why I got tangent square x over tangent square x. And next we're supposed to copy the top and add the fractions in the denominator. I have 2 over tangent x over tangent square x plus 1 over tangent square x. This is equal 2 over tangent x. Division I'm going to change to the multiplication, and the fraction from the denominator I'm going to flip upside down. In other words, I have to find the reciprocal of the denominator, which is tangent square x over tangent square x plus 1. Tangent and square will cancel out. So I'm going to have 2 tangent x over tangent square x plus 1. Now, let's take a look what we can do over here. We're supposed to, this time, use the quotient relations, and we can do simply something like this. 2 times sine of x over cosine of x over sine square x over cosine square x plus 1. This is equal to sine x over cosine of x over sine square x over cosine square x plus, in the denominator I'm going to have cosine square x, and in the numerator I'm going to have cosine square x. I just convert 1 to fraction. Cosine square x over cosine square x is equal 1. I have cosine square x because in the denominator I have cosine square x, and this is going to be equal to sine x over cosine of x times, I'm going to convert division to the multiplication, and if I want to convert division to the multiplication, I'm supposed to flip the second fraction, in this case denominator, upside down. In other words, I have to find the reciprocal of it. This is cosine, this is my common denominator, cosine square x over sine square x plus cosine square x, where sine square x plus cosine square x is equal 1. This is the Pythagorean relation. Anytime you multiply fractions, you're supposed to check first if you can reduce any denominator with any numerator. Please notice that in this denominator I have cosine x, and in this numerator I have cosine square x. This cosine x will cancel out this square. And I end up with 2 sine x cosine x over 1. 2 sine x cosine x, this is nothing else, just the sine of twice an angle. So this is equal to sine 2x. Now let's take a look what we have obtained. We have sine 2x. So we just proved that the left side of my identity is equal to the right side. Let's take a look at this example. Again, we're supposed to prove that the left side is equal to the right side. I'm going to start this time from the left side. Let me copy this down first. I have cotangent alpha over 1 plus cotangent alpha. Next, I'm going to use the quotient relations. I'm going to rewrite cotangent as the cosine alpha over sine alpha over 1 plus cosine alpha over sine alpha. This is equal. I'm going to organize the denominator first. So let me copy down the numerator. I have cosine alpha over sine alpha over, and because I have 1, I'm supposed to write simply sine alpha over sine alpha, because my denominator is sine alpha. If you are going to convert 1 to fraction, so the common denominator is going to be sine alpha. In order to find out the numerator, you have to also multiply 1 by sine alpha, plus cosine alpha over sine alpha. This is equal cosine alpha over sine alpha. Division, I'm going to change to the multiplication, and I'm going to find the reciprocal of the denominator. Don't forget that we have already common denominator, which is equal sine alpha. This sine alpha will go to the numerator, and in the denominator you are going to have sine alpha plus cosine alpha. We have multiplication of two fractions. Anytime you have multiplication of fractions, you're supposed to check if you can reduce any denominator with any numerator. And I can reduce this sine alpha and this sine alpha. And I end up with cosine alpha over sine alpha plus cosine alpha. And this is nothing else, just the right side of my original identity. So this is the proof that the left side of my identity is equal to the right side.